Hello class 10, as we are discussing, this is radioactivity. So radioactivity is the phenomenon of spontaneous emission of alpha particles, beta particles and gamma radiations from an unstable nucleus, remember. So it is the nucleus of, so to say, an unstable atom which is emitting alpha beta particles and gamma radiations. So therefore it is a totally nuclear phenomenon, remember that. Radioactivity, it is a totally nuclear phenomenon because these radiations, this radiation more precisely, and these two particles are emitted from the nucleus of an unstable, atom. Now basically, like I was saying, elements or atoms having atomic number greater than 82 are unstable. These are very heavy, elements will have very heavy nucleus, okay, like the mass number will be of the order, like this, 238. This is one example I'm giving, that of uranium having atomic number 92, of course. So uranium, the nucleus of uranium is unstable and therefore this is radioactive. Okay, this will be radioactive and thereby emitting alpha beta particles and gamma radiations all the while. Spontaneously it will be emitting at any instant, at any moment it will be emitting, remember. And this phenomenon of radioactivity, that is this phenomenon of emission of alpha beta gamma radiations, it is not dependent on the mass of the substance itself. You may have 1 gram of uranium, you may have 1000 kilogram of uranium, they are all radioactive. Remember, they will be emitting alpha beta particles and gamma radiations. Now, like we've already discussed, to give you a recap, alpha particles, they are helium nuclei. Okay, so one alpha particle is a helium nucleus, that is a helium atom which is stripped of its 2 electrons. And since it is helium nucleus, therefore it is positively charged. Alpha particles are charged particles and they are positively charged. Beta particles are electrons, and electrons basically are negatively charged, and gamma radiations or gamma rays are electromagnetic waves, so therefore they have no charge, remember. Now say we have a lead box over here, and this lead box has a small opening over here, and inside this lead box we have, say, uranium, a radioactive substance. Say we have uranium inside this lead box, uranium-238, say for example here. Now this uranium-238 being radioactive, it is spontaneously emitting alpha, beta, gamma. So these particles and radiations are being emitted. Now what is seen is, if we have an electric field set up, okay, so this is the positive terminal, this is the negative terminal, so that electric field is in this direction. Electric field is from the positive terminal to the negative terminal, always remember. So there is an electric field in between these two terminals, in between these two plates, so to say. So what is seen is, since alpha and beta particles are charged particles, so they get deflected by the electric field setup. And this pink line over here, this line over here, you can see it gets deflected, but it gets deflected later than this particle. Okay, so this, therefore, since it gets deflected quickly and it gets deflected towards the positive terminal, so therefore this is your beta particle. This is your beta particle. And actually it is from this kind of an experiment that people got to know that the radiations or particles that are emitted from radioactive substances or unstable nuclei are charged. And it was seen that one of the radiations, it goes undeviated, it is not deflected by electric and magnetic field, so therefore that radiation is your gamma ray. Okay, and this line towards the right hand side, that is of course your alpha particle. So this is your alpha particle. So this is your alpha particle. This is the alpha, I'm only writing alpha, this is gamma ray, this is your beta particle. Okay, it is from this kind of an experiment that people got to know that alpha particles have heavy mass, so therefore they get deflected later than your beta particle. It is from this kind of an experiment that people got to know that beta particles have lesser mass, therefore they get deflected earlier. Whereas gamma particles, since it is chargeless, okay, it is chargeless, therefore it goes without any deviation. So this is what happens for alpha and beta particles and gamma radiations when they are placed in an electric field. So now these are the difference between alpha, beta particles and gamma radiations, remember. So as we've already mentioned, alpha is helium nucleus, beta is an electron, and gamma is an electromagnetic wave or electromagnetic ray. So since this helium nucleus, alpha is positively charged, beta is negatively charged, and gamma radiation, it's chargeless, no charge whatsoever. Therefore, since alpha is positively charged, therefore it gets deflected towards the negative plate or negative terminal in an electric field. Beta being negatively charged, it gets attracted towards or deflected towards the positive terminal in an electric field. Gamma being chargeless, it is not deflected in an electric field or a magnetic field. Whereas remember, alpha beta particles, they being charged, they will be deflected of course in an electric field and of course also in a magnetic field. Now, since alpha has the highest mass, it is a nucleus. So therefore, alpha has the highest mass. Gamma is massless, it is a radiation, it is an electromagnetic wave or ray, therefore it is massless, it has no mass whatsoever. Now this being an electron, it has mass but much lesser than that of the nucleus, alpha particle. Therefore, since alpha has the highest mass, therefore it has the highest ionizing power also. So to say, if alpha particle, say this is the alpha particle, if alpha particle having very heavy mass is traveling through a gas, okay, these are the molecules of the gas, okay, so what happens is it gives one dash to the electron going round about the nucleus in a particular atom, and the electron goes off its track or it goes off its orbit. Therefore what happens is the atom gets ionized. Alright, so this alpha particle can go on ionizing, different atoms. So therefore alpha particle has the highest ionizing power since it has the maximum mass. Beta particle has ionizing power lesser than that of alpha, of course, because it has lesser mass than alpha. Gamma rays, they have the least ionizing power. Since they have no mass, they have the least ionizing power. They can easily penetrate, so to say, through any medium, through any gas. And finally, okay, let me talk about gamma radiations itself. Gamma radiations, they being electromagnetic waves, they have the highest penetrating power. So gamma radiations, do not forget, they being electromagnetic waves, they are traveling with 3 into 10 to the power 8 meters per second. This speed, the speed of light, basically we say, okay, but it is the speed of any electromagnetic wave. Alright, so gamma radiations being traveling with this high amount of speed, they have very high penetrating power. Gamma radiations can easily penetrate through our skin. Alright, whereas beta particles have penetrating power lesser than that of gamma, of course, but more than that of alpha. And alpha particles, they being heavy particles, they being nuclei of helium, so therefore they are heavy particles and they have the least penetrating power. Alpha particles, mind you, cannot penetrate through our skin. So this is about the differences of alpha, beta and gamma, the most important differences. You might be asked questions regarding the penetrating power, regarding the ionizing power of these, alpha, beta particles and gamma radiations. Now let us look at what happens when a certain unstable nucleus emits alpha particle. Now these things are very, very important for you all to understand. So say we have any general unstable nucleus X having mass number A and atomic number Z, okay, that is the parent nucleus, so to say. So when this emits an alpha particle, as you can see, this is the helium nucleus, which is the alpha particle. So when this parent nucleus emits an alpha particle, what we get is, this is the daughter nucleus. So to say, a new nucleus is formed on the whole. Altogether, a new nucleus is formed. And this nucleus has atomic number Z minus 2. Since it has the atomic number for helium is 2, okay, so the nucleus, so the atomic number, so to say, of the daughter nucleus is Z minus 2, and there will be a decrease in the mass number of the daughter nucleus by 4. So this is what happens. Altogether, this parent nucleus becomes a new nucleus on the whole with the emission of alpha particle. For example, you have, say, uranium-238 having atomic number 92. So this is one nucleus of uranium, say, for example. It emits alpha particle. So what happens is its atomic number, the atomic number, so to say, of the daughter nucleus is lesser by 2. So the atomic number becomes 90. So the element having atomic number 90 is thorium. Alright, and the mass number becomes 234. Okay, since the mass number is lesser by 4. So uranium gets converted to thorium with the emission of alpha particle, of course. Okay, so you can remember this one reaction, this particular reaction, to show alpha emission. So with the emission of alpha particle, remember, this unstable nucleus or this unstable nucleus on the whole turns into a new nuclei. Alright, so this is what happens in alpha emission. The mass number gets decreased by 4, that of the daughter nucleus, of course, and the atomic number gets decreased by 2. Do not forget this. Likewise, let us look at beta emission. So this is a parent nucleus which is emitting a beta particle. Okay, so this is the symbol of a beta particle, do not forget. And the daughter nucleus, what happens is, since the electron has no mass number, so to say 0, so therefore there is no change in the mass number of the daughter nucleus. The mass number of the daughter nucleus formed and the parent nucleus, it's the same, A. But what happens is, the atomic number of the daughter nucleus gets increased by 1. Since the atomic number for electron, so to say, is minus 1. Okay, so therefore, the change in the atomic number of the daughter nucleus is Z plus 1. For example, we have 14C6. This is the radioactive isotope of carbon, remember. I had told you that elements having atomic number greater than 82 are radioactive. Most elements having atomic number greater than 82, they are radioactive. But there are exceptions, in which case, elements having atomic number lesser than 82 are also radioactive. Okay, some isotopes of certain elements, like for example, this isotope of carbon, 14C6, is radioactive, whereas 12C6 is the most widely available form of carbon, but this is not radioactive, whereas the isotope of it, 14C6, is radioactive. So this radioactive nucleus, carbon, it emits a beta particle, as you can see, and thereby what happens is it changes to nitrogen because its atomic number gets increased by 1. 6 plus 1 becomes 7, and the element or substance having atomic number 7 is nitrogen, so 14 and 7. So this is an example of beta emission. Now talking about gamma emission, since gamma is an electromagnetic ray, it does not have, it is massless. So therefore, this is the parent nucleus. There is, with the emission of gamma ray, there is no change in the daughter and the parent nuclei, remember. The parent nucleus and the daughter nucleus, they are one and the same. Only thing is, there is a star over here, as you can see, asterisk, in case of the parent nucleus. This represents that the parent nucleus is an excited nucleus, whereas the daughter nucleus is not excited. Okay, so excited nucleus means whenever we are excited, what happens? We are full of energy, we are pumped up. All right, likewise, and we can have excited nuclei also, we can have excited atoms also. Okay, so this is an excited nucleus, so to say it has a bit more energy than your daughter nucleus, and that bit more energy that the parent nucleus possesses, it gives out in the form of electromagnetic ray. Electromagnetic ray, this is also light, electromagnetic waves are also form of energy. So therefore remember, this excited nucleus, by giving out energy in the form of electromagnetic ray, becomes stable. This is a stable, so to say, stable compared to the parent nucleus, of course. Alright, so this is kind of unstable, and by the emission of gamma it kind of becomes stable compared to your parent nucleus. Let me not write stable over here, let me write not excited simply. Not excited. I'm not getting the opposite of excited right now, so let me simply call it not excited daughter nucleus. Alright, so no change whatsoever in the daughter and parent nuclei when in the emission of gamma radiation. Only thing is parent nucleus is excited and daughter nucleus is not.